Started. Wait.
Good evening, everyone.
Wait for 10 seconds.
Okay.
Started. Yes, you can start.
Started. I've seen it on my phone separately.
Good evening, everyone, and welcome to the second public lecture in the Vigyan Vidushi program. My name is Deepa Chari, and I'll be coordinating this lecture. As you are already familiar, Vigyan Vidushi is a first summer school organized by TIFR for women students pursuing their first year MSc in physics discipline. It is a 3-week school started from 1st of June 2020, and this year it is conducted entirely on an online platform. And a part of this program includes participants interacting with 6 eminent women physicists through a special lecture series. It is my pleasure to introduce Professor Shobhana Narasimhan to deliver the second lecture on the Vigyan Vidushi dais today. The title of her talk is Does Science Have a Gender? Reflections of Women and Science. This lecture is also being live streamed on YouTube to reach out to the wider audience. I'll now introduce our speaker, Professor Shobhana Narasimhan. Professor Shobhana Narasimhan received her MSc from IIT Bombay in 1985, where she was the Institute Silver Medalist. During her MSc in 1984, she was a student of Visiting Student Research Program at TIFR. And in 1991, she obtained her PhD from Harvard University, USA. After postdoc at Brookhaven National University, USA, and Fritz Haber Institute, Berlin, Germany, she joined the faculty of Jawaharlal Nehru Centre for Advanced Scientific Research, Bangalore in 1996, where she still works as a professor in the Theoretical Sciences Unit. She is a fellow of National Academy of Sciences, USA, and American Academy of Arts and Science. In addition to her research in computational nanoscience, she has a strong interest in promoting the cause of women in science and in teaching physics in developing countries. I now welcome Professor Shobhana Narasimhan and request her to deliver the talk. There will be a Q&A session at the end, so those who are participating through Zoom, you can type your questions and also raise your hand. I can see those questions through chat window, and I'll pass it on the questions to Professor Narasimhan on your behalf. And we'll also try to include some YouTube questions if possible. So over to you, Professor Narasimhan.
Okay. So thank you. It's a great pleasure for me to give this talk. So to start with, I'm going to ask you to do a little game. I've played this before, but I've never done this on Zoom before, so it's a little bit different. Wherever you are, I want you to shut your eyes for a minute and just see what vision you see when I say the word scientist. Okay, so now, of course, this thing is frozen again. So let's hope it gets unfrozen. Okay, so when I say the word scientist with your eyes shut, what picture do you see in your mind? Okay, so wherever you are, I hope you all have remembered what picture you're seeing. Open your eyes now. Now, my experience is, especially if you're physics students, most people see Einstein. Okay, and usually wherever I am, I do a show of raising of hands. It's a little bit hard to do in the Zoom format, but maybe at the end, maybe in the chat, you can all say how many, if you saw Einstein, just say, write Einstein in the chat, and later we'll see how many of you saw Einstein. Okay, if you're Indian, then many of you would have seen C.V. Raman. I find that my experience is also in India, a lot of people see Abdul Kalam. People see Stephen Hawking. Sometimes, so that's a little bit more unusual. Sometimes people see some old famous physicists like Archimedes. or they see some generic picture of some person wearing a lab coat. Okay. Now, what do all these scientists have in common? Okay, so usually I wait for the answer, but since it's Zoom, I have to tell you the answer. And of course, they're all very brilliant scientists. They're all physicists of one kind or another. But the thing that they all have in common, in addition to that, is that they are all men. And even in a format like this, where most of you are women students, and this is a talk about women in science, people still see a man when they hear the word scientist. That is their mental picture that corresponds to the word scientist. Very, very rarely, I have heard of some people saying that they see Marie Curie, but it's very unusual. So the question I have is, why is that? Why is it that we so strongly associate the idea of being a scientist with a mental picture of a man? And another question I have for you, which you can think about during the talk, is here's a picture of 4 people. You may know some of them, you may not know some of them, but I'm going to ask you, do you think there are any scientists in this picture? And if so, who do you think is a scientist? Maybe all of them are scientists, maybe none of them are scientists, but I just want you to guess, if you don't already know them, who you think is a scientist. So this obviously is a related question of what we think a scientist should look like. So this is my talk. I've titled it, Does Science Have a Gender? And it's a general talk about various aspects of being a woman in science, which I've sort of designed with the audience in mind of this talk, which is mostly young women who are doing their MSc and are at the stage where they're having to decide whether they want to continue in science as a career, whether they want to go into research, whether they want to do a PhD. And since this is not a very common career choice for women, I thought we would talk about some of those aspects. This picture in this cover page is a picture of children. It was drawn by a child who was asked to draw a scientist. So over the years, for many years now, 50 years now, people have been asking children to draw scientists. And initially, they always drew only men in lab coats, men doing experiments, etc. But like this drawing shows, nowadays, increasingly, children are sometimes drawing women when they draw a scientist. And this, I think, is a very encouraging development. And of course, all of you are studying science. So clearly, things are changing, but are they changing fast enough? And what can we do to make things easier for the women who are choosing to do science? This is some of what I want to talk about. So about me, I'm a professor at the Jawaharlal Nehru Centre for Scientific Research in Bangalore, as you heard. And I just have one slide about what I do. So my students and I, this is a couple of pictures of me with my students. We do research in the area of computational nanoscience. In the top picture, my students are trying to act out what is called a spin spiral. And basically, we design new materials. So the periodic table, this Lego picture, in case you don't recognize it, is supposed to be the periodic table. And the elements of the periodic table are like our Lego blocks. And we use them to design new materials on the computer with certain applications in mind. So I'm not going to talk more than that about my research. So why is it that people visualize a man when they think of scientist or physicist? That's of course because most of the famous scientists, most of the famous physicists have been men. But there have also been some remarkable and successful women scientists from very ancient times to current times. And they have had to generally overcome major difficulties and discrimination in order to succeed. And some of them are familiar names like Marie Curie, but many of them we don't know about. So I thought I would just start my talk by mentioning a few of them, just so that we're aware that there are successful women scientists who have made major contributions to science. So one of the most ancient ones we know about is Hypatia of Alexandria. So she was of Greek origin, but she was in Alexandria, which is in Egypt. So she was a philosopher and mathematician, and she wrote a commentary on this famous book called Arithmetica by Diophantus, also on the Conica. She edited a version of Ptolemy's Almagest. Almagest you might have heard of. It's an ancient astronomical text. And also she edited a commentary on Euclid's Elements by Theon of Alexandria, who was her father. But her story is not an entirely happy one. She was a very controversial figure, even though she was very admired. And eventually she was attacked and killed by a mob. And there's a movie called Agora. It came out maybe 10, 15 years ago, which tells her story, Agora. So if you want to know more about her, you can see this movie. This picture on the right is a piece of chemistry equipment, which most of you have probably seen. It's called an Alembic. It is what you use to distill. And it's actually, again, a very ancient piece of equipment. It was first invented in the 3rd century AD. But what people don't know is that it was invented, and what people don't know very often is that it was invented by a woman. Her name was Cleopatra. She was also from Alexandria. She was not Cleopatra, the queen of Egypt, whom most people have heard of. She was an alchemist. Alchemists were the people who tried to find a way to convert base metals to gold. But in the process, they also made very important discoveries in chemistry. And she was a very famous alchemist. I'm moving forward many centuries now, and I'm talking to you about Laura Bassi, who was a quite remarkable physicist, but again, most people have not heard about her. She was the first woman in the world to get a university professorship in science. She got a doctorate, and later she was a professor at the University of Bologna in Italy. And she did research in Newtonian physics. And while being a professor and doing research, etc., she also had 12 children. And it's also very interesting to know that when she was appointed to her position as a professor, her husband was appointed as her lab assistant. So that's a very interesting story, I think. Marie Curie, I'm sure most of you have heard of, all of you must have heard of. She's probably the most famous woman scientist ever. She formulated the theory of radioactivity. She discovered radium and polonium. She was very much in a minority. For example, when there was the International Congress of Physicists in Paris in 1900, amongst the 836 participants, there were only 2 women, and she was one of the 2 women. She won 2 Nobel Prizes, one in physics and one in chemistry, and only 2 other scientists have won 2 Nobel Prizes in science. She had 2 daughters, one of whom also won a Nobel Prize. She had to struggle a lot to make her scientific discovery. She's also talked about how difficult it was to manage the research and the housekeeping and the cooking and looking after the children. And she was also attacked a lot by people who did not like her. And there were a lot of attacks against her in the newspapers, etc. There were also lots of people who admired her, but there were also a lot of people who led sort of newspaper campaigns against her, etc. So her life wasn't completely easy. Emmy Noether, I don't know, some of you might have heard about her. She's famous for Noether's theorem. Noether's theorem, in case you don't know it, it is a theorem that connects symmetries with conservation laws. Since you're physics students, you all know that there are laws of conservation of momentum, conservation of energy, etc. And she showed that each of these conservation laws is related to a fundamental symmetry principle in physics. So for example, if you have rotational symmetry, then you have conservation of angular momentum. If you have translational symmetry, you have conservation of linear momentum. If you have symmetry in time translation, then you have conservation of energy, etc. She also made very, very important contributions to mathematics, but she had to really fight to study because they didn't want to admit her to study. She studied in Germany, and they said that, you know, she shouldn't be allowed to study because she was a woman. So she was only allowed to audit classes, that she wasn't allowed to be an official student. And then they appointed her as a lecturer and as a professor. But they said because she was a woman, she could teach, but she couldn't be paid for her teaching. And they used to call her Der Noether. Der is in German, is masculine article. So that means that they're saying she's like a man. And when they wanted to hire her in this position, which in German is called Privatdozent, it's sort of like a junior faculty position, many people said you can't appoint her because she's a woman. And Hilbert, who was a very famous mathematician, when he fought for her appointment to go through, he said, I do not see that the sex of the candidate is an argument against her admission. After all, we are a university, not a bathhouse. Then she had to flee Germany because the Nazis came to power and she was Jewish. And then when she went to the US also, the big universities, which were male universities like Princeton, would not hire her because she was a woman. And she finally got a job at Bryn Mawr, which was a women's college. Now I come to Kamla Soni, who was an Indian biochemist and who I think deserves to be a household name in India. And it's a pity that she is not. She was the first Indian woman to get a PhD in any branch of science. She was a student at IISc in Bangalore, the Indian Institute of Science. And at that time, C.V. Raman, who was at IISc, refused to admit her as a student because she was a woman. And he was worried for two things. One is he thought because she's a woman, she won't be a good scientist. And secondly, he thought if there was a woman student, she would distract all the male students and they would be looking at her instead of doing their work. So she had to really fight. She staged a satyagraha. And then finally he gave in and admitted her. And she did very important studies, like she showed the nutritional value of milk, of dal, of neera. She also discovered this enzyme called cytochrome C. There's Anna Mani, who was an Indian meteorologist and physicist. She was also a student of C.V. Raman. There's a story about her that in her family, when girls turned 11, they were always given diamond earrings as a birthday present. And she said, no, I don't want diamond earrings. I want an encyclopedia instead. And she says my being a woman had absolutely no bearing on what I chose to do with my life. And she said, it must be getting difficult for women to do science these days. We had absolutely no such problems in my time. But that's not really so. They did have to face a lot of problems. Another very famous woman is Rosalind Franklin. She was an X-ray crystallographer, and she made the first X-ray pictures of DNA, which were very influential in getting Watson and Crick to develop the double helix model of DNA. But the exact sequence of events remains controversial, because it seems like her pictures were shown to them without her permission by somebody else. And Watson and Crick got the Nobel Prize for finding this structure. She had unfortunately passed away by that time, of cancer. But Watson wrote this famous book called The Double Helix about how they found the structure. And that became very controversial because he wrote really nastily about her. I mean, he criticized the way she looked, the way she dressed. He complained that she didn't wear lipstick, though in this picture you can see she's wearing lipstick. And he complained that she wanted to do research on her own instead of just helping men do research, things like that. Hu Yu is a Chinese chemist who was trained in both pharmacy and traditional Chinese medicine. And during the Vietnam War, she was asked to find an anti-malarial treatment because a lot of soldiers were getting malaria in Vietnam. And by screening a lot of traditional Chinese herbs, she discovered artemisinin, which is a very powerful anti-malarial agent. And she also volunteered to be the first human subject. So the first human being on which this was tried out as a treatment was herself. And 5 years ago, in 2015, she was given the Nobel Prize for this discovery. Jocelyn Bell Burnell discovered pulsars. So I suppose you know about pulsars. They're these pulsing radio sources in the sky. And when she discovered them when she was a PhD student, and nobody believed her when she made this discovery. They kept saying, no, this is some mistake you've made. This is some artifact in your experiment. And even her PhD guide didn't believe her. But finally, they published this paper in Nature. And then, of course, when they gave the Nobel Prize for the discovery, the Nobel Prize was given to her PhD guide, who had not believed her, and she was not given the Nobel Prize. And this is considered one of the big scandals of the Nobel Prize, that she was left out. Though a couple of years ago, she was awarded the Breakthrough Prize in Fundamental Physics, which is a prize of $3 million. And she decided that she didn't really need the money anymore. And she has used it to set up a fund to support women in science and refugees who want to study science. Miriam Mirzakhani was an Iranian mathematician who then went on to the US. So when I suppose you all know about these international competitions for students called the Olympiads. They're there in maths and physics, etc. So when she was in 17 and 18, she twice won the gold medal in the International Maths Olympiad. And then she went on to become a mathematician who worked on the geometry of curved surfaces. Now, as you may know, in maths, there is no Nobel Prize, and the most prestigious prize in maths is called the Fields Medal. But the Fields Medal is special because you have to be under 40 to win it. And in 2014, she became the first woman to win the Fields Medal. Unfortunately, she died very young. She died shortly after she won this Fields Medal, again of cancer. Now, do you recognize these two women? This was the picture I had shown you where there were four people in a picture. There was a man and three women. And the two women in the middle of the picture, they were the two scientists. And sometimes people guess it, but sometimes don't. People often think the man looks just like the scientist. The woman on the extreme right, incidentally, is Cameron Diaz, who's a Hollywood actress. So these two women are Emmanuelle Charpentier and Jennifer Doudna, and they're biologists. And they developed this technique called CRISPR, which helps to edit DNA. And they have won several major prizes for this work. And it's pretty much expected that they will soon win the Nobel Prize for this. And in 2015, Time magazine named them amongst the 100 most influential people in the world. And these women, I suppose, you might have heard of recently. So ISRO is well known for having many women scientists who have had important leadership roles. So for Chandrayaan-2, both the project leader and the mission director were women. And so that's, I think, a very remarkable thing. I don't think that's happened in any other countries. So they got a lot of attention for that. I don't know, maybe some of you also saw this movie, Mission Manga, which is about the women who work for ISRO. But so I had very mixed feelings about this movie because it was nice that it was featuring women in science and giving prominence to the problems they face. But at the same time, the way it portrayed them, I thought was a bit problematic. Like this scientist portrayed in this picture, she gets her ideas while making puris. And that's what's being shown in this picture. And I mean, I don't think there's anything wrong in making puris, and there's not anything wrong in getting inspired by making puris also. But there's more to being a woman scientist than that. We don't only get our ideas when cooking. We are every bit as mathematically trained and scientifically trained as the male scientists. And that should be given full credit, I think. So I've told you about some of the women in science, but we have to ask ourselves, why are there so few women in science? Okay, so I don't know. I'd be interested to know in your classes how many women there are in science. Girls and women often have less self-confidence in their ability to do science. Women have to spend a lot of time in housework and childcare, which makes it difficult for them to devote time to a scientific career. And social and cultural attitudes do sometimes result in women being discriminated against. It could be explicit, like somebody could say, oh, you're a woman, you can't do science. But that's not so common nowadays. Sometimes it's much more subtle. You may not even be aware that you're discriminating against someone. And more importantly, sometimes you may not even be aware that someone is discriminating against you. So this is a picture which shows the percentage of women amongst the working scientists in the country. And the darker the color, the greater the percentage. And the important thing here is that the only country in the world which has more than half of the scientists in the country being women is Burma, Myanmar. I don't know what is different about Burma. We have to find out. And everywhere else, most countries, it is 10%, 20%, 30% of the scientists are women. And given that typically women are 50% of the population, so that is not represented in the scientific community. So what about India? So I have to say that I was quite surprised by this because, as you heard in the introduction, initially I studied in India, then I did my PhD in the US, and then I did one postdoc in the US and one postdoc in Germany, and I traveled to many countries for conferences and things. And my general impression was that relative to many countries, India is doing quite okay when it comes to women in science, but the statistics tell a different story. So this graph here shows the percentage of women, of scientists in that country who are women. And this only shows the Asian countries, and they ranked according to what percentage of women they have. So right at the top, you have Myanmar, where like 70% of the scientists are women. And then it comes lower, 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 lower. And India is right at the bottom. That red box there is India, where about 14% of the working scientists are women. So that's really low. And in all of Asia, only Nepal has fewer women amongst the working scientists. Nepal has about 7% women. And all our neighbors have a higher percentage of women amongst their scientific community. So that is Bangladesh has higher, Pakistan has higher, Sri Lanka has higher, etc., except for Nepal. They all are doing better than us when it comes to the percentage of women amongst working scientists. And this I find very surprising. I don't understand why. So I call this the enigma of India. So the enigma is something that's a puzzle. So I find this very puzzling. Why are we doing so badly? Because in some other fields, which are also traditionally male dominated, we're not doing so badly. So for example, if you think of airline pilots is, again, if you hear the word pilot and you close your eyes, I'm sure you will see a picture of a man wearing a uniform. You won't typically see a picture of a woman. But if you look at the percentage of pilots in an airline who are women, this is amongst all airlines in the world, then the three airlines which have the highest percentage of women pilots, female pilots, are all Indian airlines. I mean, the percentage isn't very high. It's about 13-14%. But Indigo, SpiceJet, and Air India are the three airlines which are the highest. So the Norwegian airline is below that, then United, which is an American airline, then Lufthansa, which is a German airline, then Air Canada, then British Airways, etc. So if Indian women are able to do better than the rest of the world when it comes to being airline pilots, I really question why are we doing so badly when it comes to being scientists. So I would be very interested to hear from you people, you young people, why you think this might be. I don't really know the answer. So now, if you look at the percentage of women or girls amongst students and faculty, etc., in the US, they have this pattern which they call the leaky pipeline. So if they look at university graduates, it's about 50%. So that's what you expect. PhD students, it drops down to 37%. Then postdocs, it's less. Assistant professors, it's less. Associate professors, it's less. Full professors, 12%. And then National Academy of Science members, that is the most prestigious thing, it's down to 6%. So as you go higher and higher and higher up, the percentage falls. In India, how does it look? So we have what I call not the leaky pipeline, but the waterfall. So if you look at science PhDs, 44% of science PhDs go to women. So that's not quite 50%, but it's not very far from 50%. So quite a few women are going on to get science PhDs in India. But as I showed you, when you look at the percentage of women working as scientists, it drops to about 14%. So we are losing most women after the PhD. Okay, so women are able to study up to the PhD and then they drop out, they leave scientific research. Okay, some of them stop working altogether. Some of them may become school teachers, college teachers, etc. So the question is, why do we lose them out? So here are some statistics from India. So if you look at breaks in education and career amongst women in India, about 25% have to break their career for their education or their career for some reason or the other. And if you look at the reason why they broke their career, for many of them, the most common reason is need to earn or financial problems. But the next most common reason is family care. Okay, and then marriage or related issues. So this is for education. And then when they resume their education, this is only looking at those who resume their education, not those who had to break their education and stayed dropped out. I think it's very interesting that the most common reason people give for resuming their education is love for science and research. So they're really driven and motivated by how much they love science, how much they love research. Okay. And what if they start working and then they have to break their career? Then the most common reason is family care. Okay, so women have to look after their family and then therefore they have to break their career. That is the most common reason. And then the next most common reason is location shift. And location shift is also, of course, typically related to getting married to somebody who lives in another city or town and having to move from one city to another. And therefore you have to leave your job and then maybe you're not able to get a job or you've moved to another city where there aren't those many job opportunities for you. And this again, I want to emphasize is statistics only amongst those women who then resumed their career. So here, there's this book called Leelavati's Daughters, which I'm sure you will hear about if you haven't already done so. And this is a book of autobiographical essays by women scientists from India. And I've just selected some sentences from them. You know, the principal addressed our class and urged the girls who had opted for science to give up their seats in favor of boys with lower marks. My husband did not want me to go away for a long time, but somehow I could convince him. I fought a lot to convince my parents about the importance of going abroad for postdoctoral studies. It was not common for a girl to study on her own in distant places. I got married, though I was not keen to get married. I had to fulfill my parents' wishes. Upon the arrival of my son, I found it very hard to devote myself full-time to research. My husband, a well-known astrophysicist, respected my wish to study mathematics, though he too did not wish me to prioritize career over family. So maybe many of you are already facing some of these issues. So we can discuss them if you wish. The government of India has realized that this is a problem that women face, that they have to often break their career or their education. And it has set up programs specifically for women who have had a break in career. Both the Department of Science and Technology and the Department of Biotechnology have programs specifically for women who've had a break in career. For example, the Department of Science and Technology has what are called the Women Scientists A and Women Scientists B schemes. Women Scientists A is if you want to be a scientific researcher, and it will give you 3 to 5 years of salary and research support. Women Scientists B is if you want to have a slight shift. For example, you want to be trained, you want to use your scientific training, but maybe not be a scientific researcher. You can go into fields like patent law, where a scientific training is still required. It has also set up women's technology parks for women entrepreneurs. So if you want to start your own scientific industry or scientific company, for example, a biotech company or something like that, for women who would like to start a company. What can you do to help you stay in science if that's what you want to do? So I put up this slide from a talk by a friend of mine called Sarita Adve. She is a computer scientist. She's originally, of course, from India, but she is now a professor of computer science in the US at the University of Urbana-Champaign. And if you go to YouTube, you can see this talk that she gave when she won this Anita Borg Excellence in Innovation Award. And she says, she concludes her talk by saying, for the younger people here, remember this, choose your life partner wisely. So, of course, you don't have to have a life partner. You may choose to remain single. But if you do choose to get married, this is something I've heard again and again from women scientists, that it's very important to choose your life partner wisely. She says, that decision was by far the most important one of my life. And for example, for Madame Curie, that was clearly very important, that she was very reluctant to get married because she wanted to do science. But Pierre Curie promised her that he would be supportive of her scientific career. And in fact, the first Nobel Prize that they won together, the Nobel Committee was only planning to give it to him and to Becquerel. And when Pierre Curie found this out, he wrote to the Nobel Committee and convinced them that she also deserved it. And then they were convinced by that finally and agreed to give it to him also. So it's really important to have someone in your family who really supports you very strongly. I had mentioned this thing about implicit bias. So why do we have this idea in our mind that, so even if I close my eyes and I hear the word physicist, I think the picture that comes first to my mind is the picture of Einstein, who is a man. But I believe so strongly that women should do science and women should do physics. So why do I have these pictures? Why, when I close my eyes and hear the word pilot, do I see a picture of a man wearing uniform and not a picture of a woman wearing a uniform? So these are all biases that are deeply, deeply embedded in us and which we may not even be aware of. And so there is this test online, which is set up by Harvard University, which you can take. And it's called the implicit bias test. And I would urge all of you to go and take this test, and you will find out, for example, do you believe that women should work in the house, or do you believe that women should do arts and men should do science? The first time I took this test, which was many, many years ago, I was quite startled to find that I apparently believed, without even being aware of it, very strongly that women should do art subjects and men should do science subjects. But then earlier this year, I took the test again, and the opposite came out. Apparently, not very strongly, but slightly, I believe females should do science and males should do humanities. But I must confess that in the meantime, I know how this test works, so I may have slightly cheated it a little bit. Okay. And why do we have these ideas? Because there's gender stereotyping, because school textbooks, etc. You know, like this is a picture I took from a school textbook showing people doing various jobs. And the only job here that a woman is shown doing is school teacher. All the other jobs, it shows men doing these jobs. And if you from very early age, you have these sort of pictures, then it gets very deeply embedded in you that, oh, women should do these kind of jobs, men should do those kind of jobs. And you may hear comments, okay, like say a man makes some mistake and they'll just say, oh, you made a mistake. But a girl makes the mistake, they won't just say, oh, you made the mistake. They'll say, oh, see, girls shouldn't do maths, girls shouldn't do science. So you may have had experiences like that, or constantly people may be saying little things which you don't even realize that they're being negative. They're not saying explicitly, you're a girl, so you shouldn't do physics, you're a girl, so you shouldn't do research, but they may be subtly affecting your self-confidence. So many studies have shown that if you look at girl students and boy students, in elementary school, boys have slightly more self-confidence than girls, which is the first bar chart on the left. In middle school, you start seeing a difference. Boys certainly have much more self-confidence than girls. And in high school,
we are at 40 minutes now.
Yeah, that's fine. And in high school, it's even more. And also, if you say, I argue with my teachers when I think I'm right, boys are much more willing to do it. Girls are more timid. They won't argue with their teachers. This study was done in the US. I tried to see if similar research was done in India. I couldn't find it, but I still think the general picture is very similar, because I have found when I'm teaching classes, if they do badly in a test, girls will come and tell me, oh, I don't think I'm good enough for this. I'm not good enough. I did very badly. Whereas boys will come and fight with me and say, you didn't give me the marks I deserved, and this test was not fair, and this question was not fair, and that kind of thing. So, I mean, of course, there are girls who are the other way and there are boys who are the other way. But in general, there is a difference in the kind of self-confidence girls have and boys have. And also, if you ask them, do you like, but girls like science, they just don't think they're good at science. So similarly, if you ask girls, do you like maths? Lots of them like maths. But if you ask them, do you think you're good at maths? Very few think they're good at maths. Now, for boys also, there is that difference between those who like it and those who think they're good at it. But that difference is much less for boys than for girls. Okay, so you have to look inside yourself and ask yourself, are you suffering from this kind of issue? Do you think you're good at physics? If you don't think you're good at physics, you should ask yourself, are you being fair to yourself? Maybe you are good at physics, but you are being unfairly harsh in evaluating yourself. And why are there reasons for this low self-esteem, especially amongst Indian women? I don't know. This is a very complex issue, but it may be the attitudes and expectations of family and teachers. There's a cultural feeling in India that it is bad to praise children. They may be giving some more weightage to certain kinds of accomplishments than others. And I also feel that Indian women are raised to believe that their happiness is secondary to that of others, and therefore they're not important. Like as Indian women, I feel we are told that it is more important that your goal in life should be to make other people happy and not to make yourself happy. And because of that, later in life, you start feeling that you have to make sacrifices for your aspirations, etc. And this also affects the way you view yourself and how confident you are about your skills and your abilities. So that's all I wanted to say. But the most important message I have for all of you is you have to stay strong and do not give up. Don't give up is very important. See, I mean, all of us who are scientists have faced difficulties of various kinds. We may have faced academic difficulties. We may have faced financial difficulties. We may have faced family difficulties. But if you see the women who succeeded and who stayed in science and who went on to have good careers, the one thing I think you find that's in common amongst all of them is that they persisted and they did not give up. So this is the message I want to leave you with. Thank you.
Thanks a lot, Shobhana. And I think now we can start taking some questions. I would first like to I would first like to start with Zoom questions, and then we'll also wait for a few seconds to get YouTube questions. So before we start, could you just give a little bit, make a comment about, you talked in terms of family responsibilities, and that could probably is one of the reason why there is a little bit of hindrance in why women make particular choices. So how, and you have been in a university for several years. What do you see like role of universities or larger universities in particular in terms of this, like how they can support women who obviously might have to deal with family responsibilities and accomplish the careers that they wanted to. So how institutes can support in this agenda? Can you comment something about that?
Okay, so I think first of all, they should give infrastructure like having daycare facilities on campus, allowing people to work flexibly. I think this is something that I'm hoping will change after this coronavirus lockdown. I think people are beginning to realize that it is possible to work from home. And maybe this, and for many women, it will be easier if they can work from home at least some of the time. But it was not culturally accepted in the scientific culture that you can work from home. There was this idea that you have to not only work, but you have to be seen to be working. You have to be there physically at work all the time. And I'm hoping that this will change a little bit now. Now, of course, it also depends whether you are an experimentalist or a theoretician. If you're a theoretician like me, it is much easier to work from home. If you are an experimentalist, then obviously you have to be at the lab some of the time. But this may also affect your decision about what you decide to go into, whether you decide to go into experiment or if you decide to go into theory. So for example, in my group right now, I have a postdoc who she did her PhD in experimental physics, but then she got married and she realized that if she wants to start a family, it is going to be very difficult to do lab work all the time. And so she switched from experiment to theory. And I decided to encourage her to do it and take her on as a postdoc, even though she didn't have experience, because I wanted to support her. So this also is important, that faculty have to be supportive of women and their aspirations. Like I took her on as a postdoc, even though she didn't have previous theoretical expertise. And I have, allowed her to work part-time when she's needed to. I've allowed her to work from home when she needed to. This kind of, I think it's also a lot of it is a mindset change.
Yeah, no, I agree. So I have another question. It is more technical one asked by Nishita. I think it was slide 34, and she's asking about, is the percentage of science researchers that you showed, what was the criteria for it? Does it takes into account permanently employed and also doctoral or postdoc students, or it was only like scientists in, so that is more
Okay,
of
so
a
these are UNESCO statistics. And as far as I understand it, it is those who are only, it says in the scientific workforce. So I think it's only permanently employed, and it does not include PhD students. It says R&D researchers, and I don't think it includes PhD students.
Thank you. I think there are a couple of questions regarding pay parity and pay parity in several several careers, and what would you like to comment something about pay parity in physics in terms of gender, like male physicist or female physicist and the occupation that they take in physics related industry as well as in academia? How is there any
Okay,
pay
so
parity?
in academia, for the most part, I would say that men and women are paid the same, at least in government jobs. There can be slight differences depending on how many increments you get or whatever. But in India, for the most part, men and women are paid the same for doing the same job in academia. This may not be the same in industry. And I also want to say this is not true in all countries. For example, in the US, all professors are not paid the same. Each professor negotiates their own salary, and often these salaries are sort of kept secret. And then when they later investigate, they find that men can be paid often twice as much as women. And so this is something that, for example, American women, when they talk to me, they will say, "Oh my God, you're so advanced in India. I can't believe that you women are paid the same as the men," because for them, it is a big issue that they're not paid the same. So, but related to this, I want to say one thing that is true is that a lot of studies have shown that women are not as comfortable as men in negotiating for things. Now, if you're working in a government scientific institute or a university in India, you may not have to negotiate your salary, but there are other things you will have to negotiate, like how much lab space you get, how many teaching hours you get, how many students you are given, many things like that. And women are not as comfortable as men in demanding things for themselves. So I sometimes conduct these workshops for women in physics where people come and train women to practice asking for things for themselves. This is part of this whole being sacrificial woman, Indian woman thing, I think. Not just Indian women, all women. We are not comfortable. We don't feel we deserve more. We feel, oh, they're giving me this much. How can I ask for more? So we have to practice saying, no, I want, I deserve. And this is very important, I think.
Okay, that is great. I have one more question asked by one of the student participant, and her question is about: is it true that female tend to do theoretical science instead of experimental science more, and if that is so, like how they make these choices?
So this is related to what I said before. First of all, I do not think the numbers support it. Actually, I think there are more women doing experiment than theory. But as I said, sometimes women will choose to go into theory just because if they have family constraints, then theory is a bit less demanding time-wise than experiment, in that you can do your calculation from home, or you can pause your calculation, whereas an experiment, you know, if your system, your vacuum chamber is you proceeding, you can't just leave it in the middle and go away and then come back later, or you know, sometimes things are very time bound and you have to be in the lab physically. So for that reason, some women choose to go into theory.
There's one more question. I mean, a group of them, but they are more or less are asking regarding retention, which you already mentioned that you don't see that there are the proportion is too less in India for women entering in science, but then this turns out to be a waterfall problem. So how institutions as 4-year institutions as well as masters and PhD institution can help them prepare for of retention of women students or women physics students in particular? Are there any strategies about it that you would like to
Okay, so
think about?
one thing that I think we should do is do away completely with age limits for jobs, because in India there is this rule, which is sometimes unwritten, sometimes written, that if you want to have an assistant professor position, for example, that you have to be 35 or younger. And I have seen advertisements that say this, or I have seen selection criteria which say this. And if you have had children during your PhD and had to take some years off or something, then it becomes very difficult for women to meet that criterion. So I think this is one thing that absolutely we have to do away with, this age limit. And you have to do away with it on paper, and you also have to do away with it from people's minds. And that is even more difficult, because even if they remove it on paper, they may just operate with it unofficially. So we have to educate people and say, look, if she's 37 because she took 2 years off to have a child, it doesn't matter. And I also think that people have to stop thinking that a break in career is suicidal for your career. Many people think once you had a break in your career, you should never, you can't come back. They say things like, oh, science progresses so fast. I personally don't subscribe to that theory at all. I believe that it is quite okay to have a break for 1 or 2 years and then you can come back, because after all the time in physics, people switch fields. And if you can switch fields and go into a new field and learn this field and publish well in it, you can also take off 2 years and come back to the field and do very well in it, I firmly believe.
That was a great suggestion, Shobhana. And I think I'll take one more question from student on Zoom. A few of them had asked that in India, we families kind of support, or families take a lot of decisions for us. So how, as a student in physics, how you would see that, what is your advice on how we can gain more family support? And when family, they are also talking about extended families, how we can help, how one can convince them about that they would like to do this particular career. And yeah, would you like to comment something about that?
Yeah, I mean, this is obviously a very difficult question, but I think, first of all, educate your family instead of fight your family, if that is possible. Talk to them about why you want to do what you want to do. Tell them about successful women who have maybe had it all. If there's a talk like this, make them also listen to it. And also, very often, I find that if you have a mentor, it could be your college professor, it could be your PhD guide, or someone like that, who is influencing you in your choice of career, you can also have them talk to your family. And they are often willing to do it, though they may be a little bit hesitant initially to get involved without your requesting them to do it. Okay, like I have done it, many of my colleagues have done it. We have talked to the parents of female students and said, look, we think she's really, really good. And we think it will be a great loss to physics if she leaves the field. And this is sometimes enough to convince the family that this person is really somebody who should continue in physics.
So I'll pass on a few YouTube questions now. One of the YouTuber have asked a question about do you have any insight for female scientists in experimental industry? Women are still to be seen in academia, but not much in industry. The women scientists are just sparse there. So would you like to comment about how do you see that we can increase participation of women scientists in industry?
So actually, my impression is that many of the industries, especially the big multinational corporations, are desperate for women employees. And if you were to apply to them, I think you would have a very good chance of being hired. For example, I am familiar with a big multinational R&D center in Bangalore. I won't tell you which one, where the head of one of the research groups was more or less told that if he didn't hire a certain number of women, because he had no women in his group, and they told him, look, you have no women, and if you don't have any women, you're going to lose your job. And so they were asking me, do you know any qualified women? We really need to hire women. So, and also from what I hear, some of these companies are far more progressive in their culture when it comes to policies that are women friendly. So I don't work in an industry, so I'm probably not the person to answer this question, but my feeling is that things are actually quite promising on the industrial front. And also if you look at even Indian industries like BEL, BHEL, etc., they have quite a few women employees.
Okay. I think I'll pass on the mic to Vandana now. She has collected a couple of YouTube questions and she would like to start with some comments of some responses that YouTubers have given to your prior questions that you asked during the presentation. So over to you, Vandana.
Thank you, Deepa. Yeah, as Deepa said, I will just first bring the response of the YouTube participants to you, Shobhana. So your question was, when you close your eyes, what do you see? You said most of them did say that they were male scientists, and some of them did say Marie Curie. But what I like,
very good.
2-3 people. One of them said, I saw myself at ISRO.
Oh, very good.
Said, I saw myself doing experiments and I saw myself. So I think this was really a very interesting.
Yeah, I'm very happy to hear that. Yeah, that's good.
And then I had one comment. I mean, it was a wonderful talk, of course, and you covered a wide canvas of from all many great women scientists to also the problems down to the grass type. So the point which you made about Mission Mangal, I just thought I would make a comment on that. Okay. It's true, as you said, nothing wrong about making puris, but that whole thing actually stereotypes again as a woman. And it struck me again because in this March, once I was in some function on 8th March, and there was this principal of a college, pharmacy college. She actually glorified this, saying that how a woman scientist should be. You have to take care of everything, and then you start up putting it like an ideal thing there. So in that sense, I feel that the Mission Mangal does more harm. Yeah.
I also have problems with that movie, as I said. Yeah.
So there have been quite a few questions on the YouTube, and some of them along the lines which Deepa had also already collected. So one question is says that, what do you think of some published studies that claim women have a natural preference towards life sciences and humanities? I have seen many people quote these.
So I have not, but without seeing the studies, I cannot comment on them. But certainly it seems to be true that if you look at life sciences, you see more women. If you see humanities, you see more women. And if you see physics or engineering, there are fewer women. But what does natural preference mean? I mean, it's very hard to say what is a natural preference. Okay, it is, you cannot take a person out from all their cultural influences, their family influences, etc. So if somebody chooses to study something, you cannot say, is that innate in them? Or because we are all products of our culture. I mean, maybe your parents gave you a doll to play with instead of a mechano set or a car or something. All these things influence your choices. So I really don't think there is any evidence at all, as far as I know, that there is a natural female preference for some subjects and a male preference for something. There are some studies which seem to suggest this, and there are other studies which show exactly the opposite. So this is a very controversial topic, and I certainly don't think that there is any evidence on this. There is a very good new book recently published maybe a couple of years ago on this question. It's called Inferior. It is about how people claim that science shows that women are not good at doing science and how this is wrong, how people are falsely making this claim. So it's this book called Inferior. I recommend that people who are interested in this question can look at this book and read it.
Okay, thank you, Shobhana. The next question I have is, how do you keep yourself motivated when you face problems while pursuing your PhD?
My PhD.
Generally, I guess the question is about general rather than or because it doesn't say specifically, but as a keep motivated, keep yourself motivated while pursuing PhD.
Okay, this is a very hard question to answer. I can tell you honestly that there have been many times when I have lost motivation, but some of it is inside me. There's a part of me that didn't give up, and I don't know where that came from. But a lot of it is also from having a supportive network of friends, mostly women, but also men, uh, who really supported me through the dark times and who boosted my confidence. Because I don't know how I seem to you now, whether I seem confident or not, but I can tell you I'm not by nature a very confident person. I often feel, I mean, I went through life thinking I'm not a good student, I'm not a good physicist, I'm not a good advisor, I'm not a good person, etc. And it was other people who really helped me, who kept saying, no, you know, you're very good, you should continue, you should do this. And, you know, I would say after my PhD, I said, I'm not going to apply for any postdocs, I won't get any postdoc position. And my friends would say, no, by tomorrow, I want you to have applied to 5 postdocs. And when I talk to you tomorrow, you should have applied, that kind of thing. So I really had a lot of support from other friends. And one thing that women sometimes face is that they may be the only woman in their department because women are so much in the minority. But it is also very important to know that your friends don't have to be physically where you are, they can be in other places. So I have a whole network of women physicists who are supportive of me, who are spread throughout the world and who prop me up even today. And nowadays with internet and Skype and Zoom and WhatsApp and everything, it is very easy to have this community network supporting you. And that really provides me with my motivation, I would say, in addition to what I have inside me. And I must say also in my case, my parents were very supportive.
So you made two important points in the talk, one about the perseverance and also about the mentoring. And I think, I mean, as one of the conveners of this program, I would like to say that this program gives a lot of emphasis to mentoring, recognizing the due importance of it. And I hope, I'm quite sure that today's your lecture has actually been very significant part of the process for all the participants. So I'll get back to Deepa now. Thank you.
Thank you.
Right. Thank you, Vandana. And thank you, Professor Narasimhan, again for the wonderful talk. We have lots of questions actually, but I think we are also tied up with time. So we'll pass these questions to you later on.
Yeah, I just wanted to say people can write to me or whatever.
Sure. And I think we'll also put your email address again on the YouTube. So live chat, so people can also pass the questions directly to you. So thanks once again. And we'll stop the live stream on YouTube now. But we'll just take a few Zoom questions if the students want to take, but just type it here in the chat and we will again pass it to Professor Narasimhan. Thank you. Once again.
So can I leave now or should I stay on?
Yeah. Yes, sure. We'll pass on the questions to you later on. Thank you, Professor.
All right. Thank you. Thank you, everyone.